Okay, so we have our x coordinate, our first coordinate, and then our second coordinate. So I guess, so this point right here, its coordinate is going to be, the first coordinate, be x plus delta x, and then f of x plus delta x. And now we have 2 points with 2 defined coordinates here. Alright, so I'll just write those out again right down here. We have x, f of x, and we have x plus delta x, and f of x plus delta x. I remember when I was first learning this x right here really threw things off. This is just all one single number right here. You got to keep in mind it's one single object, this x plus delta x right here. Okay, so we're going to use our slope formula up here, y2 minus y1 over x2 minus x of 1, to find the slope. So I'll just even label it as m is equal to, okay, so this is like our y2 here, so f of x plus delta x minus our f of x over, this would be x plus delta x minus x. Now, as you can see here, we can cancel some things out. In other words, this x minus x, those guys can be canceled out. So now we're left with f of x plus delta x minus f of x, and it's all over delta x. So that's going to be finding the slope of the secant line. That would be this guy right here. Now we're going to use the power of the limit. We want this delta x right here to get closer and closer and closer. In other words, to get smaller and smaller. We want the x plus delta x to get closer and closer and closer to x by letting this number right here go getting smaller and smaller and smaller. In other words, approaching 0. So this way our secant line becomes our tangent line. Okay, the good old tangent line has all kinds of applications out there. So now we could say now that f prime of x is equal to, we could say it's equal to m, but I'm saying that it's equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Now let's go back to our original problem. If you remember right, the original problem was f of x is equal to 5x plus 2, and when we took the derivative of this using the limit, f prime of x was equal to 5. Now let me just sketch out this graph right here. So f of our 5x plus 2 is going to be something that looks like this. Okay. But if you were to pick a point somewhere on this line and you wanted to know, okay, what's the tangent? What's the tangent line look like at this particular point? Well, the tangent line is this line, and the slope of this line is 5. So that's the reason that no matter what we plug in to our derivative, the slope is going to always be 5. Okay, so this may not be clear yet, but it will be eventually, because we're going to work another example on this.